Hi guys, I'm Paul McWhorter and we are here on lesson number 8 for the Arduino microcontroller. And we're going to start expanding out a little bit in the things that we can do today. And to look at it, what I've basically got running here is I've got the code that we've been working with. You know, for a lot of these first lessons, we've been working with this same schematic of this same circuit of blinking two LEDs. And we've just been building the code up little by little by little. If you go to my website, the address is in the description of this video. You can get the schematic for this circuit if you want to build it. And you can also get the code where you can sort of catch up to where we are. I wouldn't recommend that you just copy this code and paste it. I would recommend that you go back and you sort of develop it yourself, because you've got to learn to code, and the only way you learn to code is to do it. And if you just copy and paste my code, the only thing that you will know how to do is copy and paste. And so I encourage you to go through these lessons and know how to build this code up on your own. Okay, but the thing is that let's zoom into one little part of this, and the part that we're going to zoom into is the part where we actually issue the command to turn the LED on or to turn the LED off. And let's come down inside of this loop, and inside of this loop, I think the last time we did it, we were looking at while loops, and so we've got it set up as a while loop. But as we are inside of this while loop, we're looping it for the number of blinks that we've input from the from the keyboard. But when we actually issue the command to the pin, we are connected on the red LED. We are connected to pin 9. And on the yellow LED, we are connected to pin 10, and so we are issuing commands to pin 9 and pin 10. Those are set up here as variables. Red LED pin is set to 9, and then yellow LED pin is set to 10. And then these wires that come from the two LEDs go over to pin 9 and go over to pin 10. So we're all set up and talking to those pins. Again, when we're going to talk to pins in the void setup, we've got to tell the Arduino what kind of communication we're going to be doing with the pins, and so we do our pin modes. We set in pin mode red LED pin as an output and yellow LED pin as an output. So that's telling it pins 9 and 10 we're going to be writing voltages to. Now when we actually come down to write the voltages, we're using what is called a digital write command. The argument for the digital write command is, first of all, what pin do you want to write to? We want to write to red LED pin, and what do you want to write? We want to write it high. When we write it high, we are putting 5 volts on that pin. To blink it, then we come down to turn it off, and to turn it off we say digital write which pin? Red LED pin. What do you want to do? Turn it low. That puts a 0 on it, so we're going apply 5 volts, apply 0 volts, apply 5 volts, apply 0 volts. And that's the implication with a digital write. Digital is either an on or off. It's either on or it's off. There's not an in-between with the digital write. And most things in the computer world work in the digital realm, on or off. Okay, but when we start building circuits and we start coming off of the microcontroller and coming out into the real world, oftentimes we want something other than just 0 and 5. We want the in-between voltages. We would like to maybe write 1 volt or maybe write 2.5 volts. And in order to do that, we need to change the command. And instead of doing, excuse me, instead of doing a digital write, we need to do an analog write. And the analog write works a lot like the digital write. So we just write analog write. We got to tell it which pin we want to write to. So in this case, we could still do red LED pin. But rather than high and low, we put a value in here. Okay, we put a value in here. But unfortunately, it's not as easy as applying a value between 0 and 5. The number that we write, the right value, is between 0 and 255. If we do an analog write of a write value of 0, we are applying 0 volts. If we do an analog write of 255, we are writing 5 volts. Okay, so what that means is to be able to work with this thing, we've got to sort of map the world of 0 to 5, which is what we think in terms of 0 to 5 volts. We've got to map that onto 0 to 255. Okay, And what I see students a lot of times do is just sort of guess, just get in there and put in numbers and guess. But you really, really need to be more methodical than that. And so let's just take a second and see if we can use all of this math that you have been learning for all these years in school and asking, when would you ever need to know it? Well, your day has come. We're going to use some of that math. And so let's think about this, and let's kind of think about it in terms of a line. And so I'm going to come here and draw an XY axis, which hopefully you've been doing many times over the last few years. And I want you to think, on this axis, we're going to have the desired voltage. This is the voltage that we would like to have. And it can be between 0 and 5. So let's kind of mark that out. 1, 2, 3, 4, 5. Yeah, I got enough space there. This would be 1 volt, 2 volts, 3 volts, 4 volts, and 5 volts. Okay? In order to get between 0 and 5 volts, what values do we need to apply? What values do we need to write? Well, we write values between 0 and 255. And so we'll put that on this axis. We'll call this 100. We'll call this 200. And we'll call this 300. And so this would be about 250. And then this would be 150. And this would be 50. Okay? So these are the voltages that we want, and these are the numbers that we write. Okay? What's the first one? Are there a couple that we know? 0 volts, we would write what number to get 0? 0. So the first number on here is the number, or the point, 0, 0. Okay, that's down here, 0, 0. That was an easy one. If we want 5 volts, what number do we write to the pin? We learned that a few minutes ago, 255. So if we want 5, we don't write 5, we write 255. So if we come out here to 5, the point that goes with that is 255, which would be right about here. So this is the point 5, 255. Okay? Between any 2 points, we can draw a line. So let's draw our line between those 2 points. Okay? And now what you can see is you can read off of this line what values that you should apply to get the voltage you want. So if you wanted a voltage of about 2.5 volts, let's come up here, you would write something that would be right about there. That looks like about, 147 or something like that would give you the value of 5. So you can use this line to figure out what values you should write to the pin to get the voltages that you want. All right, but you don't want to carry this graph around with you the rest of your life to try to figure out what voltages to write. So it would be smarter to try to come up with an equation that captures the information in this line. And so let's write an equation for the line. To write an equation for the line, what's the first thing that you need? Well, you need to get the slope. The slope is equal to y2 minus y1 over x2 minus x1. Okay, and so what are our 2 points? 5, 255, and 0, 0. So let's put those in. Y2 would be 255 minus y1, which is 0, over x2, which is going to be 5, minus x1, which is 0, which is going to be equal to 255 over 5, and the slope is going to be 51. Okay? So now I have a slope, but I want the equation of the line. Well, to get the equation of the line, we can use the point-slope formula because we have the slope and we have a point. But it's going to be easier. You can use whichever point you want. To use the point-slope formula, it's going to be easier to use this point. And so let's use that one. Do you remember the point-slope form of a line? It's y minus y1 is equal to m onto x minus x1. So we're going to have y minus, what is y1? It's 0, is equal to m, what was m? 51, onto x minus, what's x1? 0. Okay? And so now what we have is y is equal to 51 times x. And we can go on and sort of remind ourselves what the x and y were. The y is going to be our right value, the value we write to the pen. The right value, the number we write to the pen, is going to be equal to 51 times the desired voltage. Okay? So the right value is 51 times the desired voltage. So if we want a voltage of 1 on the pen, what should we write? We should write 51 times the desired voltage. 51 times 1, we should write 51. If we want 1 volt, we should write 51. If we want 2 volts, we should write 51 times 2, which is 102. So you see, with this little equation, we can get any voltage that we want on that pin because we can calculate the right value. And go ahead and do it with the math rather than just sitting and guessing numbers until you get something that works. Do it with the math. Okay, so we'll put this aside, but we now have the equation that allows us to get the voltage that we want on, let's see if I can get both of these things on here. All right. Okay. So we're going to start playing with this code now a little bit. Okay, we're going to start playing with the code. And the first thing that we want to do is that if we want these in-between values, the first thing that we're going to have to do is not use these digital write commands. You see how we say digital write LED, red LED pin high? We want to change that to an analog write. Okay, so we're going to change that to analog write. And notice the case, analog write with a capital W, just like it was before. But now red LED pin high, we still have to tell it what pin to write to. But now, instead of high, we're going to put a number in there. And if we wanted to write 1 volt to that pin, 1 volt, what would we write here? Our write value would be 51 times our desired voltage 1 would be 51. That would apply 1 volt to it. And if we applied 1 volt instead of 5 volts, I'm betting that we can notice this to be perceivably dimmer. Okay? Now, same thing here. This still turns the thing off, but still, once we start doing analog writes, I think that we should just use analog writes. So we're going to change this analog write. Now, if we want to turn the pin off, we want to apply 0 volts. And so what would we write value? It would be 51 times our desired voltage. 51 times 0 would be 0. So to turn it off, we would do a write value of 0. And let's do it with the yellow pin as well. And I'm going to keep my code. I'm going to keep my comments good here. So here we're going to analog write, or I'm going to say we're going to apply analog voltage to pin. And then this is still good, turning it off. And then here what we are going to do is we are going to apply analog voltage to the yellow LED. Okay, and it's good practice to sort of, it's kind of real easy to correct your code and to change your code and not keep your comments in line with it, and you really need to keep your comments changed as you're changing your code. Okay, so and then here we are going to turn our, and this is just a perfect example of how I didn't do that. Okay, and then for yellow. Okay, and so I think we've got this. I think we've got this in pretty good shape here now. I think we've got it in pretty good shape. Okay, so now when I write this, I've got to fix these things too. So I'm going to make this analog write. So we're going to go analog write, and we want yellow pin, and we want a value of 1 volt. And so 1 volt times 51, we would write the number 51 in order to get 1 volt. And then here we are going to analog write a value of 0. So what we've done is we've gone into this program and we have changed our digital rights to analog rights. And so let's download this and see what happens now. Hoping it's going to work here. It's hanging up here just a second. It is not happy. Let me make sure I got all my stuff closed out here. Okay, let's try it again. Yeah, sometimes if you get the orange stuff down there, you just got to try it a couple of times, and sometimes it takes 2 or 3 times, but it will usually get it. And when you have that, usually you don't have a real good serial connection, and the best thing that you could do is to replace your USB cable, which I need to do, but I need this long one because it is the only one that'll make it all the way over here. So you're just going to have to be patient. And sometimes it just doesn't get the okay, but it did download the code. Okay, that time it looks good. So now let's call up our serial monitor. And remember our program from earlier. Let's try it again. How many times do you want to blink the red LED? 5. How many times do you want to blink the yellow LED? 5. And now it is blinking. And unfortunately on the camera you can't see, you don't have that much fidelity, but with my eye I can see that it's very, very, very much dimmer. Okay, the LEDs are very, very much dimmer. It's just hard to capture that on the camera. Maybe what we need to do is maybe we need to really make it a lot lower than that. Instead of 1 volt, how about we went like 1/10 of a volt? So that would be 0.1 times 51. What if we just wrote a 5? Let's even see if we can see that. Write a 5, and then down here in the other one, we're going to write a 5 as well. And so we're analog writing a 5. Well, what voltage are we getting if we write a value of 5? Well, we're getting we're getting about 1/10 of a volt, because if we say the desired voltage is 0.1 times 51 means we would write a number of 5. And let's see if we put that down there. I'm hoping I can get the LEDs to the point that you can actually see on the camera that they're dimmer. Okay, let's try this again. Okay, and most of the time, okay, that looks like it likes it. Okay, we're going to blink it 5 times. How many times do you want to blink the yellow? 5. And let's see. Yeah, I think you can see now that that's really, really dim. I think even on the camera now that you can see that that's dimmer. Let's go down. I wonder how low we can make this to where we can still see the LEDs, like how small you can put it. Let's just for fun see if you could see a 1. Like if we wrote a 1, which would be like 1/50th of a volt. That would be really low. But let's see if that's enough to turn the LED on. And so analog write a value of 1, which would be 1/50th of a volt. So let's see what happens there. Okay, let's call this up, and then let's say 5 blinks, and I want 5 blinks. Ooh, can you even see it? Yeah, you can kind of see it. You barely see it with that little voltage. If I turn the lights off, maybe you can kind of see how dim that is. Okay, so do you see? With the analog write, we can write all the numbers between 0 and 5 volts. We can write any voltage that we want. And certainly that's something that's neat to do to dim the LEDs, but you can also imagine like running servos or motors or other things, all types of different things. A lot of times you want those in-between values. And the way you get those in-between values is doing an analog write. I'd like to just practice a little bit here, some of the stuff that we've learned. And so I want to go back and kind of review what we did in last week's lesson about doing input. And so this time, what I want to do is I don't want to input the number of blinks, and so I'm going to hardwire the number of blinks in here. The number of yellow blinks I'm going to hardwire into 5 as 5. And the number of red blinks I am going to hardwire into 5 as well. And so the program, rather than getting input from the user, is just going to come in and it's going to blink the yellow LED 5 times and it's going to blink the red LED 5 times. Okay? But I do want to input something, and what I want to input is I want to input, and let me just change this. Remember, what 3 things do we have to do to get a number from a user? Number 1, we have to prompt the user to input that number, and we prompt the user doing a serial print line. And I had this set up for a different parameter, but let's just change this to make it give us the right value that we want. Okay, so serial print line. We're going to prompt him for, what number do you want to write? So what number are we going to write to that pin? Okay. Well, now what do? We got to wait for it. When we prompt the user for input with the serial print line, we can do the serial print line because we've done the serial begin over here. We can do the serial print line, prompt him for a number. What do we have to do? We have to wait. And how do we wait? We wait with a while serial available is equal 0, do nothing. And so what this is saying is, ask him for the number and then wait here on this line until he puts the number in. When he puts the number in, serial available will go to 1. That tells you that the number has been put in, and then you come down here and read the number. But now when we read the number, we don't want to read it into num red blinks. No, we want to read it into write value. That's the value we're going to write to that pin. Right? That's the value that we're going to do the analog write with. Well, if we're going to use a new variable here, write value, we better declare it up here, and it's a number between 0 and 255, and so we're going to make it an int, and we're going to call it write value. Okay? And we're going to declare it here. Declare variable for write value. Okay? And we're going to have 2 write values because we're going to write a value to the red LED, and then we're also going to write a value to the yellow LED. So we're going to have write value yellow. And so that's the value that we're going to write to the yellow LED. Okay. Declare variable for write value yellow. Okay, and this is declare a variable for write value red. I better put the W down here. Okay, comments, it just lets us know what's going on. Arduino doesn't really read it. And so now when we come down here, let's read write value red. Okay, and what number do you want to write to red LED? So this is the number that we're going to write to the red LED. And so this is kind of a brightness number. And we should also probably tell the person that it needs to be between 0 and 255, just so that they know that's what we're asking for. Okay, and then now for this one, we're going to input the number for the yellow LED. So we're going to use this code, just kind of modify it here, serial print line. And what are we going to say? We're going to say, what number do you want to write to the yellow LED. Okay, and it needs to be between 0 and 255. Okay. I should probably put a question mark in there just to be good. Okay. So we're going to prompt the user. After we prompt the user, what are we going to do? We're going to wait for his input by doing a while serial available is 0. As long as he hasn't put the number in, it's just going to sit here looping in this little space here doing nothing until the number comes in, and then he's going to come down here. And then we need this to be write value yellow is equal to the number that you go get off the serial port. So you're going to go %, you're going to go read an integer off the serial port. So let's look at what we're doing here. We've just modified that old code, and I hope it wasn't too confusing, but it was easier than writing it from scratch. This time we've hardwired in. Every time we run it, the red's going to blink The red's going to blink 5 and the yellow's going to blink 5. But the thing that we're going to input from the user is the brightness number. And the brightness number can be from 0 to 255. If we input a number of 0, we apply 0 volts. If we input a number of 255, we apply 5 volts. And so we're scaling the voltage that we're applying to that LED from 0 to 5 volts by inputting a number from 0 to 255. Okay, does that make sense? And let's see, I think that that should all work, but then down here now when we write the values, the analog write, we need to analog write to red LED pin that thing that we got up here, that number, which is write value red. Okay, and then down here we need to put in to this one write value yellow. Okay, so we come up and we get the brightness value from the user for red and the brightness value from the user for yellow. Then down here in our analog writes, we write the red value to red and we write the yellow value to yellow. I hope this all makes sense. Let's run this and see if this is going to work now. Okay. I am going to have to get a new serial cable, but I do not have one, so you're going to have to be patient with me. Okay, there it goes. It worked that time. Okay. What number do you want to write to the red LED? Well, let's make it real dim. Let's write a 1 to it. So that would be 1/50th of a volt. What number do you want to write to the yellow LED? A number between 0 and 255. Well, let's make that one really bright. So let's make that one 255. Okay, and so now let's look what happens. You see the red, you can barely see it, it is so dim, but the yellow is really bright. Let's turn the light off and look at that. So you see the red is at its lowest value of 50th of a volt, and the yellow is at its full value of 255, which is 5 volts. So you can see the yellow is blinking really bright, and the red is blinking so dim that you can't even see it, hardly. Okay. So let's run this again, okay? And I can actually hit the reset button to start it here again. You see the reset button, I can just hit that and it should start the program again. Okay, it says what value do you want to write to the red LED? Well, let's make the red bright this time, 255. What do you want to write to the yellow? Let's make it 1. Let's make the yellow dim and see what happens, okay? So look how bright the red is, full blast, and the yellow, you can barely see it blinking. The red is full blast. The yellow, you can barely see blinking. Let's try another one. Let's make them both sort of dim, like let's say 1/10 of a volt. Well, 1/10 of a volt, if we wanted 1/10 of a volt, it would be 0.1 times 51 would be 5. So let's write 5 to the red and let's write 5 to the yellow. So they should both be blinking sort of dim. So I'm going to write 5 to the red and I'm going to write 5 to the yellow. Okay, you see the red is kind of dim and the yellow is kind of dim. The red's kind of dim and the yellow's kind of dim. So what you can see here is that with these analog writes, we can write whatever voltage that we want between 0 and 5 volts to these Arduino pins. Okay, there's still, I should say that when we're writing to these pins, even though we're doing an analog write, we still have to do our pin modes. We still have to set those 2 pins up as outputs. We still have to do our pin modes, but now when we do analog writes instead of digital writes, we can get all the in-between values between 0 and 5 volts. The thing that you just have to remember, and I see people make this mistake over and over when I'm helping students, they say, oh, I want to write 2 volts, so I do an analog write of 2. No, you have to scale that number with the math that we did. The right value that you use is 51 times the desired voltage. Okay, and if you remember that, it'll work perfectly. So we've learned something new and powerful, that now we don't just have to turn a light on and off. We can get a scale. We can get it just barely on or almost all the way on. We can control that voltage that we're applying. And as we start working with more sophisticated components and start working with other components besides the LED, you're just going to see how important and how powerful that is. Okay, this has been a little bit of a tedious lesson because of all the math, but if you get confused, just go back and watch this again as far as is how we went through this equation to make this whole thing work. And also there's some descriptions on the website. You can get the website from the description of this video. Okay guys, we will see you very soon in Arduino lesson number 9. Take it easy.